So in this video, I'm going to explain z-scores, and then we'll do an example from an IB Math SL exam of a question that involves z-scores. So this is a concept from normal distribution questions, and it'll say right in the question, your data is normally distributed or follows a normal model. So you'll know it's a normal distribution question. And a normal distribution is the bell curve. I think when given a normal distribution question, it's always a good idea to sketch yourself a bell curve. Using the information that's given in the question and labeling it on there is a good idea. So for example, you might have test scores are normally distributed with a mean of 80 and a standard deviation of 5. So we're thinking one standard deviation above that mean, one standard deviation below that mean, and these should be evenly spaced out. Do that again to get to the next standard deviation, and then one more time to get to the third standard deviation. That's as far as you need to label. There's only a tiny percent of the data that would lie outside of 3 standard deviations above and below the mean. And then we should be familiar with the percentage of the data that lies within each of these regions. So no matter what your x-axis is, if it's the weights of soda cans that are normally distributed or test scores, the weights of newborn babies, whatever it is they're telling you is normally distributed, the percentage of data that falls between a mean and a standard deviation is always 34% approximately, whether it's one standard deviation above or below the mean. That's what it means to be normally distributed. That 34% is going to fall between the mean and the first standard deviation, 13.5% in the next standard deviation, and only 2.5% in the last standard deviation. And that adds up to 100%. Truthfully, it should add up to more like 99.7% because there's a tiny percent left, less than 1%, that might lie outside of the 3 standard deviations. But for the estimates, we can use these figures. Now, what a z-score is, it's just taking your x-axis and forcing it to have a mean of 0 and a standard deviation of 1, so that we could talk about all normal distributions the same way. Because even if this was weights of soda cans, the green percentages are the same. So no matter what values go on your x-axis, a normal distribution looks exactly the same. So standardized values on the x-axis are what z-scores are. So any value that is one standard deviation less than the mean of your data set would have a z-score of -1. So in our numerical test score data, that would be like getting a 75 on the test. Because that's one standard deviation below the mean of that data set, a 75 there has a z-score of -1. 80 would have a z-score of 0 because it is the mean. 95 would have a z-score of 3. And there are values that exist in between each of these. So like a 91, which would fall here on the x-axis, would have a z-score somewhere between 2 and 3, perhaps 2.112 or something like that. And so z-scores can be decimals. They're always going to be between -3 and 3 for almost all the time. And they can be negative or positive, because if it's to the left of the mean, it'll have a negative z-score, and if it's to the right of the mean, it'll have a positive z-score. So it's just taking the units out of your x-axis and standardizing the units all to be decimals between -3 and 3, so that no matter if your data set is about test scores and mine is about weights of babies, we can talk about the percentages, which are always the same. So let's find an example where we'll have to use z-scores, and there is a z-score formula in our formula booklet to help us. And it tends to be when they give us a normal distribution question and ask us to find the mean or find the standard deviation, rather than telling us the mean or the standard deviation. In this question, they're actually asking us to find both the mean and the standard deviation. So if they're not giving you a mean or a standard, that's when you know you're in a z-score question, for the most part. So you want to consult your formula booklet. You'll find that there's a formula that says to get the z-score for any particular value in your data set, you do the mean minus that data value. Okay, so that's the data value. The mu symbol is mean. So mean minus the data value and divide by the standard deviation of the data set, and you'll get the z-score there. So that's how, in the previous example, a 95 would turn into a z-score of 3, would be by doing that calculation. So for this question, the age at which babies develop the ability to walk is described by a normal model. So I'm going to start by drawing myself a normal curve, and any information they give me, I'm going to try to label in the correct spot on my bell curve. They're telling me it is known that 5% of babies learn how to walk by the age of 10 months. So that's going to be way down here, with only 5% of babies learning how to walk before they reach 10 months old. 25% need more than 13 months. So I've located the information given on my normal distribution, and I don't know the mean and the standard deviation, so I can't label all the other vertical lines here. I can't label the one in the center that is the mean. What I am going to do is try to figure out what is this 13 and this 10 on the z-scale, right? On the z-score x-axis instead of on this x-axis. And that I have enough information to do. So if the mean of this data set was 0, I'm trying to figure out where 13 would fall on the z-scale. So it's going to be probably somewhere between 1, 2, and 3, right? Most of the data is within 3 standard deviations of the mean. So it's going to have some sort of z-score that is positive, maybe between 1 and 2, maybe between 2 and 3. To figure it out exactly, I'm going to go to the calculator and I'm going to use inverse normal. So I'm trying to find the z-score that corresponds with this 13. What I know is that 25% of the data lies above it, which means 75% of the data is below that 13. So that red 75% is what I'm going to have to use when I go to inverse normal on the calculator. So I'll go over to inverse normal on the calculator. It's on the menu probability distributions option, and we're going to do an inverse normal calculation. And you'll see that the mean and standard deviation are automatically filled in as 0 and 1 when I don't change it. And that's what I want. By hitting enter here, it's going to give me a value on the z-scale, where the mean is 0 and the standard deviation is 1. What I need to tell it is I'm looking for the one where 75% of the data falls below it. So you always have to put in there the area below, or the percentage, but express it as a decimal, below or to the left of the z-score you're trying to find. And so now I know that that 13 corresponds with a z-score of 0.67449. We want to not round that value. That's just something I need along the way to the answer. So if I was to record that here, 0.67449, let's go back to being green. That's what I have my z-scores as, 0.67449. So now I know that this 13 months is somewhere between the mean and the first standard deviation, because the first standard deviation would have a z-score of 1. So now I know that 13 corresponds with a z-score of 0.67449. I need to do the same thing for the 10 months. I got to figure out what the z-score is associated with that. For the 10 months, I can see it's 5% of the data to the left of it. So I'm going to go back to the calculator, do another inverse normal calculation. Menu, probability, distributions, inverse normal. Area is 0.05. And I want the mean of 0, standard deviation of 1, so that it gives me a z-score. So negative 1.64485. Negative 1.64485. Negative 1.64485. Okay. I still don't know the mean and standard deviation of this data set, but now I have a data value and the z-score that goes with it, another data value and the z-score that goes with it. So I can take those two pieces of information and use the z-score formula twice. Once it will be 0.67449, which equals the mean minus 13 over the standard deviation. And the other z-score I know is for the data value of 10. So what I'm setting for myself up is a system of equations where I have two variables unknown, the mean and the standard deviation, and two data values and the corresponding z-score values. So you use the percentages that are given to find the z-scores for those data values, and then you set up the z-score formula, in this case twice, so that we can solve for both of the missing variables. If I did know one of the things, like maybe I knew the mean, then I could fill that in and I would only need one of these equations in order to find the standard deviation, or vice versa. But if they're not giving us both, then I'm going to use the formula twice and do a system. I would solve this by passing the standard deviation to the left side of each of these equations. And notice again that I'm not rounding these z-scores because we're not yet done with the problem. You shouldn't round in the middle of a problem. So I would take this linear equation, and pass this standard deviation to the other side as well, equals the mean minus 10. Should be an equal sign there. Take this linear equation, and I would solve, since this is a calculator question anyway, we needed it to get the z-scores, I would use my calculator to solve this linear system of equations by going to Menu, Algebra, Systems of Equations. And I could just type these in, and it'll solve for the standard deviation and the mean for me. Or you could try to solve them on your own by the substitution method. And that is all.